More examples about trigonometry proofs is what we are going to see in this lesson, but please don't forget to subscribe to the channel. Now, we have an interesting proof here. It says, if A, B, and C are angles of a triangle, then prove that this is equal to this. The hint we are going to use here, we are going to use the hint of double angles. We are going to use the difference of the squares. We are going to use the sine rule. We are also going to use the factor formula, and also this idea of sine 180 minus a is equal to sine of this, because this is a second quadrant and sine is positive in that quadrant. Now from here, you know the sine rule. We have seen also how to prove that sine rule. Now you see that this is equal to this. If I make a the submit small a, I'm going to get this cross multiply it here and get sine a, and 2r equal to a. Like you see, c over sine c is equal to this. You get c, you get this times this here. The same to b, remember this is equal to this, so if you cross multiply, you get that in that order. Let us see now. This is going to be our left hand side and this is our right hand side. If I also now my left hand side, you see a squared minus b squared is c squared here. Now I know what a is, I know what b is, and what c is. Now these are sides, so I substitute them there. Now when we square this, we get 4r squared sine squared a. Then square this, I get 4r squared sine squared b. And then square this, I get 4r squared sine squared c. And so now 4r squared is common, we factorize it out. And from here, start with this and this are going to cancel. So remain with only this over this. If you have the square, the same as multiplying them like that. And up here, we see a difference of two squares, sine squared a and sine squared b. This is how we handle the difference of two squares there. Get the first and the square, we add, then we subtract the two. That's why I get sine a minus sine b, then sine a plus sine b. Now, from angles of a triangle, we know that a and b are angles of a triangle. That angles of a triangle add up to 180 degrees. So from here, a plus b plus c, they add up to 180 degrees. Now, instead in my proof I have a and b, it means that I don't need this c. So that's when I use the angle sum of triangle. So if you make c the subject, now we take this to this side, we have it. Now it's going to be the whole of this, now minus the sine. Introduce sine, because we want to remove this sine c. So introduce sine both sides, is what we get. And now, using this idea here, that's when we see that sine of 180 minus sine, and then minus a plus b, is the same as sine of this, the same as sine of a plus b. So there is the sine c, is now going to be equal to that using this property here. Now from there, we also know, now that's where, from here, I substitute this, where the sine c, I put sine a plus b, sine a plus b. I'm seeing that this is already there, I don't need this. Now here I apply factor formula. When we are subtracting, it means that we are going to subtract in sine, so we get 2 sine a minus b over 2, then cos a plus b over 2. Then if we are adding, then we add here, so a plus b over 2, then cos here, we subtract as we can see. Then from here, we have finished the lessons about factor formulas. I mean, you can go and visit them. Now, from here, after expanding this, the whole of this is here. But remember, you're multiplying, that's why I said diagonals. The whole of this is here, using this idea. Now, here, be careful. Here, I'm using the double angle. When is this? I'm substituting this using the double angle of sine. What does it say? It says if we have sine Ka, where this is the coefficient, the same as 2, the same angle that you divided this coefficient of a, the angle by 2. So from here, my sine a plus b now is the angle. You see its coefficient is 1. So we get this angle a plus b divided by 2, but the same angle divided by 2, the double angle of sine. So this angle divided by 2 and this angle divided by 2. Now here, we're using the double angle of sine, this one here. You get the angle, reduce it by 2. The angle where k is the coefficient of the angle. So that here our angle is a plus b, its coefficient is 1. So you divide it by 2, you get this by 2, you get that 2 sine that. So that's why where there is this, I'm putting this from there. Now here you see, because all this is the product, start now, first of all, I can cancel something. Start sign, the whole of this is cancelling with this. Then also this is here, so the whole of this is cancelling with that. So what am I going with? I'm seeing also that these two can go with these two. So what I'm remaining with, you see that there, I have now 2 sine the whole over 2. Then I also remain with my cos the whole over 2. I divide it with now sine A plus B, which we want already. So we want to see if we can reduce this. Now we know that from the same idea, sine of A minus B, we have sine of A minus B. We can also use the double angle here. This will be 2 sine of, now we reduce this angle by 2, the whole of this by 2, so it's going to be A minus B, the whole over 2. Then the same angle, reduce it by 2, then with cos over 2. Still using the double angle of sine. This angle by 2, we have that angle. Then also this by 2, as simple as that. So from here, you can see that now our left hand side will be now equaling from here, which was 2 sine the whole over plus b. Now you see that the whole of this is sine A minus b over sine A plus b. And so our left hand side now is equal to this, which is equal to our right hand side. But our left hand side was a squared over c squared, now is equal to 2. Now over a plus b, and c we have that. So that's it, members. I wish you